go. We're almost to the end, guys. This is section 13-6, the tangent function. So we talked about the sine function and the cosine function. Now the tangent function. These are the three main trigonometrical functions that we're going to be talking about. And then after we talk about these three functions, there are reciprocal functions. Reciprocal functions for each of these. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. We'll talk about that in the next video. But right now we're going to concentrate on tangent today. And we're only going to do example 1 of section 13-6. We're going to skip 13-7. Then we're going to go into 13-8, which is going to be reciprocal functions. We're going to go into those reciprocal functions and how to find the actual answers to the reciprocal functions of angles. Okay, so sine and cosine, we already talked about that before. The sine and cosine of an angle are derived from the coordinates on the unit circle. Remember, where the x coordinate of a point on the unit circle is the cosine, and the y coordinate of a point on the unit circle is the sine of theta. Whatever the angle measurement is of theta will tell you what the coordinates of the point are on the unit circle. That's how we got all the answers for sine and cosine. Tangent is similar, but a little different. These points, the coordinates of the points of the tangent are not on the actual unit circle. They're on a line that is tangent to the unit circle. Tangent means a line that touches the circle in one point only. A line tangent to a circle, again, is a line that just skims a circle and touches only at one point. This is the line x equals 1. It's a vertical line that crosses at x equals 1. And to get the answers for tangent, the tangent of an angle derives from the coordinates of a point not on the unit circle, but it derives from the point on a line that is tangent to the unit circle. And this is the line that's tangent to the unit circle, x equals 1. And x equals -1 will be giving you the other side. But for now, we're going to concentrate on x equals 1. So again, you can look at a unit circle. The x equals 1 is going to be the x coordinate of the points on this line. Any point on this line, x equals 1 is the x coordinate. And depending on how the angle is, how big the angle is, theta will tell you the y coordinate. So tangent of theta is the y coordinate of a point on the line tangent to the unit circle. They're not actually on the unit circle like sine and cosine are. So again, here's another definition for tangent of theta. Is the y coordinate of the point on the line tangent, on a tangent line, x equals 1. So the x coordinate is 1 always, and the y coordinate is the answer to tangent of theta, whatever theta is. So again, if you can look at the unit circle, if I wanted to find the tangent of 30 degrees, I would have to draw a line. I would have to draw this line here, which is x equals 1. And it's tangent to the unit circle. And then to find the tangent of, let's say, 30 degrees or pi over 6, either way, you'd have to extend this line, and it meets here. Whatever the y coordinate is here is the tangent of 30 degrees. Same thing with the tangent of 45 degrees. Extend the 45 degree angle, where it meets on the line tangent here is going to be, well, always the x coordinate is 1. And the y coordinate is going to be the tangent of 30 degrees. And you can get these answers by simply putting your, if you're talking about tangent of 30 degrees, you put your calculator in degree mode and you go tangent of 30. You get the answer. That's going to be the answer right there. Tangent of 30 degrees, you can get it from the calculator. But also to get it, this is how you get it in math. You draw a line tangent and you find the coordinates that way. The tangent of 60 degrees, again, is going to meet way up here somewhere. Okay, way up here. It's going to be the x coordinate is 1 always, and the tangent of 60 degrees, you can get it from plugging it into the calculator and figuring it out. This is the tangent of 45 degrees, or the tangent of pi over 4. You know, you can do it in radian modes or in degree modes. Tangent of 90. What do you think the tangent of 90 is? Here's 90 degrees. Is the 90 degree ever going to touch this line if I extend it? No, they're parallel, aren't they? Since they're parallel, I bet you the tangent of 90 degrees or the tangent of pi over 2 is undefined. You can look it up on your graphing calculator to see. But that's how you get tangent lines. Tangent lines are not coordinates that are on the unit circle like sine and cosine were. They're coordinates that are on the line tangent to this. And there are some undefined. The domain is not going to be all real numbers like sine and cosine, because sine and cosine, every x value, every angle measurement of theta had a output, had an answer. Here, the tangent of pi over 2 doesn't work, because look, it can never touch. There are parallel lines. They will never cross this line tangent to the unit circle. Okay, now that we said that, let's go to example 1. We're only going to do example 1, so this is going to be a short video. Example 1 says finding tangent values from a graph. Here's the graph of the tangent function from negative pi over 2 to pi over 2. We're not going to actually graph the tangent function here, but we're just going to look into how to find what the actual answers, the outputs are to the tangent of different theta measurements. And they can be in radian measures or they can be in degree measures. Here they're in radian measures. So finding these measurements, what you could do is you can put your calculator in radian mode and then do pi over 4. Let's see if that works. Let's see what the answer would be. But if I look at the graph, let me get the answers from the graph first, then we'll check them on the graphing calculator. Or in any calculator, any scientific calculator that has these trig functions, which all of them do, all you got to do is you got to figure out how to put the calculator in radian mode. Here it's already in radian mode, not in degree mode. That's the graphing calculator. So you have to figure out, put it in radian mode because they're in radians. If they were in degrees, you put it in degree mode. And then you go tangent of pi over negative pi over 4. But let's look at it over here. To find it on the graph, you already have the graph. The tangent of negative pi over 4 is the value here. And it's negative 1. It should be negative 1. What's the tangent of 0? Well, that's 0, right? Tangent of 0 is 0. The input is 0. The output is 0. Input is the x value. This is the x value. This is the y value. The tangent of pi over 4, here's the x value is pi over 4. And the y value seems to be 1. So 1. Let's see if we get the same answers here. We go tangent. Alpha y equals enter. Or you can do pi divided by 4 of negative pi over 4. Pi is going to be, I'm going to use the pi. I'm not going to put 3.14. I'm going to use actual pi. Second function pi over 4. Close the parentheses. Oh, I think light will help here. Oh, good. Let's turn the light on. That makes a difference. Parentheses, enter. Oh, negative 1. Is that what we had? Yes, negative 1. Let's see the tangent of 0. Tan of 0, parentheses, equal, enter, 0. Let's do the tan of pi over 4. Tan of pi over 4. Again, let me try pi divided by 4. I did alpha y equals enter, but I bet you pi divided by 4 will be the same thing. Parentheses, enter, and it's positive 1. So yeah, we had the right answer. We checked them on the calculator. And that's it. So right now, you can do a quick check number 1, page 750. Try to do it on the graph first, using the graph, and then check your answers on the graphing calculator to see what you get, and see if you get the approximate answer to the tangents. Okay, I think that's it. Your homework would be from this section, would be a very short assignment. It'd just be page 751, number 1 through 8 all. Again, just to get a little feel of what tangent is and how tangent is found, how the values for tangent are found. Thanks, guys.